Dear students, I welcome you for the today's lecture related to the flow patterns developed in the agitated vessel. Now the selection of type of the impeller that depends on the generated flow pattern and the amount of the mixing required or the purpose of the mixing that is required. The purpose of mixing that can be whether I want a blending of the two miscible liquids, or you only simply require a solid suspension, or you may require the dispersion. Then you can be, it can be a dissolution process or crystallization process, or it can be a purpose for simple heat transfer and sometimes for chemical reaction. So all these are your purpose. So depending on this purpose, my type of the impeller, the selection of the type of the impeller that depends, and the generated flow pattern that helps for this fulfilling this purpose. So basically the purpose of the impeller or the purpose of the agitation is to fulfill the purpose of the blending, suspension, dispersion, dissolution, crystallization, heat or mass transfer, or chemical reaction. That purpose should be solved with the minimum amount of the energy required. And for that purpose, it is essential to understand the flow patterns, because the generated flow patterns that are going to give you or serve this purpose. Then the different types of the impellers that we have talked, that is the anchor type, propeller type, the turbines, paddles, then the screw type. All these are your different flow pattern, different impellers. And these impellers, that is whether it's a very close clearance with the vessel, or whether it's a high speed impeller, or whether it's a slow speed impeller, or the shape of that impeller, then what are the dimensions of that impeller. All these are going to vary depending on the different purpose. Then the position of the impeller, that is also essentially to be understood. Generally it is the centrally situated impellers, they are most common, or they are the preferred one. That is the centrally placed impeller in a baffled vessel. Now the centrally placed impeller, that means the axis of the shaft and the axis of the vessel, they will be going to coincide. So this is going to solve the purpose when we are placing the central located axis of the impeller. Then even the centrally located axis of the impeller that is there, it can be a single impeller or can it be a double impeller. As in the first figure A, that is the centrally placed impeller in a baffled vessel. Then there can be a single baffle, or there can be the multiple baffles that can be there. One is centrally baffled and another is the off-centric. That is, it is not situated in the center. That means off-centered. So centrally situated and off-center, that is the one type. Then single impeller and multiple impellers, that is the another type. Then in off center you can have the different classes, that is the side entry, the C figure, that is the agitator with a draft tube and with a side entry of the impeller. This side entry of the impeller in this figure, it is associated or attached with the draft tube. This is the draft tube. When the draft tube is provided, that is helping the movement, circular movement of the fluid, that will be helped. So rotation of this will be the possible increase in the rotation of the fluid in the axial direction, that will be increased when you put the draft tube. Then the side entry, that will be also associated. Now this side entering propellers or side entering, that is the one can be completely horizontal as in the figure C, or with a certain angle that can also be situated. Not only a single side entry, but B figure shows the two impellers with a side entry, but they are inclined at a certain angle. So that that is in the big tanks, generally these two impellers, they can be used. It is preferred only for us big tanks and with a smaller impeller diameters. Then the bottom entry, that is the bottom figure, this is the bottom entry that can also be there. So the different entries, that will be depending, or that depends on the process requirement. The provided agitator should fulfill the purpose with the minimum amount of the energy consumption. Now there can be the shaft diameter which can extend up to the bottom also. So here up to the bottom, you can, means from one side, one end, it will start the impeller and it will end at the another end. So at both the ends, the, that means for a vessel, if this is the vessel and it is a shaft entering at the one end and will be ending or fixed at the another end also. So complete throughout shafts, they can also be used. Again, that depends on the process, that depends on the viscosity of the fluid, that is very much essential or very much important in the process of the agitation. Viscosity, density, speed of rotation, diameter of the impeller. So all these are the very basic parameters in the process of agitation. So centrally situated baffle, off-centric baffles. Off-centric baffles, you can have the side entry, you can have the bottom entry. Number of impellers, that can vary. Then the single impeller that will be used, multiple impellers that will be used. Then the shaft is overhang, shaft is fixed at the another end. So all these are the different variations in case of your positioning of the impeller or design layout of the mixing equipment. Now actually coming to the flow pattern. The generated flow pattern, that is primarily distinguished in your axial flow pattern and the radial flow pattern. And the third one, that is the tangential flow pattern in case of your unbaffled vessel. Whenever you call it axial flow and the radial flow entry, axial flow and the radial flow pattern, that is concerned with the baffles. Now what are the baffles? If you will look at this figure, the walls, they are attached with a simple metal piece. The shaft if this is the wall of a vessel, and to this wall of a vessel I am providing a plate, and this plate prevents the swirling motion, the simple rotation of the vessel that will be prevented by this baffle, and this helps in creating the turbulence in the vessel. So axial flow pattern and the radial flow pattern. Axial flow pattern is nothing but you are parallel to the axis, shaft axis, and radial flow pattern, that is towards the radius, towards the wall of the vessel, from shaft of the vessel towards the radius, that is the radial flow pattern. And third is the tangential flow pattern, that is associated with the unbaffled vessel, which is simply a swirling rotation of the fluid that will take place. Now, mostly we are having the mixers. Now, if you will look at the mixer, this is the primary purpose or the primary agitator which you see in your day-to-day life. And all these mixers do serve all these flow patterns. Mixers, the pot, if you will see the liquid pot or the juicer pot of a mixer, it is provided with a certain baffles, or you can say the certain grooves, to make it useful for cleaning purpose. It can be provided with a certain grooves. Now you are in your house, almost all of you are in your house, you can see these mixer pots also, and can show in the figure. If you will look at this bottle, there are certain grooves which are provided, right? So similarly, these grooves, they are also designed in your agitation pot or the liquid pot. So this helps the purpose of a baffle, and which creates the turbulence also. As it creates the turbulence, the tangential flow, or simply the swirling motion, that is prevented. What is swirling, we will see afterwards. So mixer is our basic agitation purpose. Now in case of our household mixers, it is provided the entry of an impeller is from the bottom, as shown in this figure, this lower figure B. It is the entry is provided with the bottom maximum type of the mixer. But nowadays these hand blenders, they are also there. So in hand blenders, it is your top entry, but we try to put it in the center generally, but it is not exactly possible to hold these hand blenders in the centrally situated position, so that can be in a off centric also. So again, that depends on the power consumption. We never think of how much amount of the power that will be required, because it's a simple 1 to 5 minutes we are using in our household purpose. But in case of industries, it's the 24 by 7 operation. So when it's a 24 by 7 operation, then the need of power consumption becomes very much essential to be studied. And for that purpose, the effective time of the mixing, that is also to be studied, and all these utilities, or and all this purpose of a study is for 24 by 7 by 365 days, or you can say the 300 days in when it is talked in terms of your technical language. Then when it's a baffle at low speed, the mild agitation is obtained in an unbaffled vessel. This unbaffled vessel, the mild agitation that is provided. So it is not getting annotated. At low speed, the mild agitation is obtained in an unbaffled vessel. Then at high speed, you require baffles, because without baffles, it will only simply swirl. So since without baffles, the liquid is simply swirled around with a little actual mixing. very little actual mixing that is observed. And in our household purpose also, if you churn the buttermilk to take out the butter actually, you need to have change the speed, you need to put the cold water. So all these are the temperature and the speed of agitation is to be varied, so that you will get a better output with a early or with a minimum consumption. Now coming to the different types of the flow patterns that is generated depending, if you will look at this figure, that is the axial flow pattern and the radial flow pattern. One by one we will see these details related to this. The This is the figure associated with a radial flow pattern. Now radial flow pattern, when you talk, it's simply a baffle which is provided with the paddle. You can say the paddle. Now I am rotating this paddle. So what will be the effect on this fluid? The fluid will move in this direction towards the outward direction as shown in the first figure, that is the towards the outward arrow that is provided. So outward arrows they are provided, and the fluid that will be moving in this direction, that is toward the wall of the vessel, that is what a radial flow direction you will get it. So with a radial flow impeller, the liquid is pushed towards the wall of the tank, that is along the radius of a reactor. Now what happens once this radial flow that impacts on the vessel wall and it moves or changes its direction in the upward or in the lower direction. So this lower direction and the upper direction fluid that forms a circulation loop into the vessel. So there are different four circulation loops that will be observed in this cross-sectional figure. So this radial flow pattern that is going to have the upper circulation loop and the lower circulation loop, and on the another side also the upper circulation loop and lower circulation loop that will be generated. So this is because of the flow pattern which is completely perpendicular to the vessel. So impellers are parallel to the axis of the vessel shaft. That is what is very much essential. Then and only then you will get a radial flow. That is the impellers. Impellers are parallel to the axis of the drive. Then the current travel outwards to the vessel wall and then either upward or downward direction. So that is what the upward or downward direction, that is directions you will be getting, and the higher energy is required compared to the axial flow impeller. Now why this is the higher energy is required compared to the axial flow pattern? Because the fluid will be directly exposed to the vertical section. Fluid, you are moving the baffles in this direction, so the fluid will be impacting here, and at the same time I will be moving the fluid in this blades are in this direction. Then the fluid will impact, but it will be very effectively sliding downwards, and the less fluid will be moving in the radial direction. So the making the or changing the blade angle, that is going to have the effect on the flow pattern. So I am getting a flow pattern in the downward direction, I am getting the flow pattern in the radial direction. Radial direction में impact directly impeller पे blade पे हो रहा है, and that is why you require the higher energy is required compared to the axial flow impeller. Now next is the axial impeller. Axial impeller, that is the rotation or circulation loops that is developed in the parallel to the shaft axis. Parallel to the shaft axis. So this is the, if you will look at these figures, this is parallel to the shaft axis. The fluid is moving in the downward direction and then in the upward direction, and again come back near the impeller, and again forced to move in the downward direction. So it's with the axial impeller, the liquid is pushed in a downward direction. Liquid is pushed in a downward direction, that is along the axis of the reactor. And for that purpose, I have provided a certain angle to the blades. Then and only then my fluid is going to move in a downward direction. ऐसे जब रहेगा तो ही डाउनवर्ड डायरेक्शन में फ्लूइड मूव होगा. ऐसे जब रहेगा तो ओनली रेडियल डायरेक्शन में फ्लूइड मूवमेंट आएगी आपकी. Vertical, it should, if it is perpendicular to the shaft axis, it will be moving in the radial direction. If it is inclined, the baffle blades are inclined uh, in the horizontal direction, then the axial flow pattern that will be developed. So you can see the different loops that will be generated depending on the liquid height and the other parameters. Now, if you will provide the baffles, now in this figure of the B, it's a bottom view. You can see the bottom view, and these are your side views. This is your bottom view which will be available. So this bottom view, you will see, observe the four different loops that will be developed in the individual section of the baffles. Generally, four baffles they are used. So individual loops that will be generated in between the two baffles. So this is the baffle tank with the three blades. That is the propeller agitator with the axial flow pattern that is generated. One is the side view and second is the bottom view. So the impeller makes an angle of less than 90 degrees with the plane of rotation. Thus resultant flow pattern towards the base of the tank, that is more energy efficient than the radial flow mixing. This is better energy efficient because the fluid will not directly impact on the uh, blades. It will be moving, or it will have a certain angle. So more effective at lifting the solids from the base of the tank. As you are forcing the fluid to move in the downward direction, the bottommost material that will be lifted in the upward direction. As you can see in this figure, it is forcing the fluid in the downward direction so that the bottommost solid material that will be moved or lifted in the upward direction, and it developed a circulation loop. So it is more energy efficient than radial flow mixing and more effective at lifting the solids from the base of the tank. Then the third is the tangential flow entry. The current acts in a direction tangent to the circular path around the shaft. Circular path around the shaft is simply rotated, that is swirling, or you can say the vortex that will be generated. And this vortex generation is a disadvantage in the process of agitation, and that is why we are using mostly the baffles. So usually it produces the vortex which is disadvantageous, and the swirling of the liquid that will be observed. Now looking at this figure, that is the paddle that is the provided, and you will be observing the radial flow. Now this generated flow will be turbulent one. Now the blade angle that will be provided, it is going to create a turbulent flow. It is going to create a turbulent flow. To some time, it this angle that is going to create the laminar flow also. So how much amount of the fluid that will be moving in the downward direction, and what is the clearance between the bottom and the shaft blades, that is going to help or distinguish between the turbulent flow pattern and the laminar flow pattern. And the next is the axial flow impeller, which is close to the bottom. Wherever the close to the bottom, it is the axial flow impeller. Now coming to the computational fluid dynamics, which is the most advanced techniques, the computational fluid dynamics that generally people talks is the CFD. And these are some of the figures from your computational fluid dynamics or the CFD, the generated flow patterns, or these are the small velocity vectors. These are the small velocity vectors. If you will look into the details, the vector, it is provided with a certain arrow that will be there. So all these are moving arrows with a certain magnitude. Certain length is already provided with a certain magnitude. कितना लंबा है वो, कितनी magnitude है, कितनी velocity है उसकी, that is also defined. Then the color of this, that is also defined. As you are seeing, the color that is going to vary from dark blue to dark red, your velocity is going to increase. So the velocity is going to increase 3.33 into 10 to the power minus 2, and it is there up to the certain magnitude is provided. So again, all these velocity vectors generated, that is, you can see the different small loops that will be generated. These small loops, how the fluid that moves, it is all defined with the help of the mathematics. When you talk mathematics, it's your computational fluid dynamics. That means your Bernoulli's equation, heat transfer, basic heat transfer equation, and the basic mass transfer equation, continuity equation. So all these are your basic equations, and from these basic equations, you are going to calculate these velocity vectors or the local velocities. All these are your local velocities. The magnitude, the quantity, कितनी meters per second की velocity है, that will be defined. Then these are the velocity magnitude that is provided in this second so the each impeller that is going to provide a different type of the uh, velocity vectors. So these are the again velocity vectors in the right hand section of this figure. It is the long velocity vectors, and in the left side it's a short velocity vector. That means the velocity is the low, and you can observe the downward movement as well as you can observe the upward movement of these velocity vectors, and that means the fluid is moving in the upward direction as well as the fluid is moving in the downward direction. Now, as you have seen this figure, here you can see the axial flow impeller with a turbulent flow and axial flow impeller with a laminar flow. So similar velocity vectors you can also observe this from the impeller shaft. You can observe this velocity vector, they are going in the outward direction as well as in the downward direction. So all these are the velocity vector that will be generated. So whatever you can think, what will be the possible movement or direction of the fluid, that is mathematically proved in the computational fluid dynamics subject. Sorry. Then your two impellers that is shown in this figure, and you can have the different velocity vector. Now the velocity of the fluid just around the impeller, it will be the more. So the velocities, it is shown in the red direction, and then the color decreases to the yellow. So from red to the yellow, your velocity decreases. And if you will look at this, in between these baffles, there are the vertical loops, they will be also developed. So you can see the different generated loops. Those who are looking at from the computer, they will understand or observe this velocity vector and the differences between that. And from mobile, it is very difficult to understand.